United States. Forests are a favorite topic of mine, especially old growth forests, and I love to visit them. And I'm going to share with you some things that I've learned over time about the forests of Quiet Waters Park. Quiet Waters Park is a perfect example of the deciduous forests of the eastern United States. And later I'll show you what the extent of those are. I worked for NASA. I worked on NASA projects for about 30 years. We use satellites to study the vegetation of the earth, deforestation, how vegetation, that included forests and agriculture, responded through the seasons in response to climate change. And satellites are ideally suited for that because they can see everywhere on Earth every day. So if something changes, if a forest is cut down or burns, we can see it with a satellite, and we can document these things and then relate that to changes in the climate and to changes in the atmosphere. A deciduous forest, what is a deciduous forest? It's made up of trees that lose their leaves when they're not in the growing season. Now, there are drought deciduous forests, especially in the tropics, where it's never cold, so it's always warm, but it gets dry certain times of the year, and times of the year, and the plants lose their leaves. Another type of deciduous forest is a forest that loses its leaves in the winter because it's too cold. It's too cold to do photosynthesis and all the physiology that the plant needs to do, so it gets rid of the leaves and then grows them back when the weather is better in the season. Now, where do deciduous forests that lose their leaves, occur and why? Well, here's a map showing these areas. This is where deciduous forests, northern temperate deciduous forests, exist in the world. There's also some down here in Chile and Argentina and Australia, Tasmania and New Zealand. These are north of the tropics, so it gets cold in the winter. So that's a factor. And then the other factor is rain. They only occur, these forests only occur where there are rainy summers. So this map is a map of precipitation. It's how many months in a year does the vegetation get more than an inch of rain? And so you see all these places where the temperate rainforests grow are places that have 0 months that get less than 1 inch of rain. So every month of the year it rains, at least 1 inch. And these wet, warm summers are very suited to deciduous forests, and that's why they grow in these places. Quiet Waters Park is a classic example. We get about 4 inches of precipitation every month of the year. It can vary from year to year. Some years we'll get 2 inches and some 9 in a particular month. And the average low temperature in January is 29 degrees. It's below freezing. This is a temperature where the plants really can't take in food, and either they have to go dormant, like some of our evergreen trees do, or they lose their leaves and don't worry about it until the weather gets better. So why are deciduous forests important? Besides being nice places to spend time, I mean, there's lots of literature, scientific work to show how beneficial being outdoors or being in forests is for your mental health and your physical health. And maybe you've heard of forest bathing. That's a new term that's been floating around about people. It's a Japanese thing that people go out and just feel good and enjoy the forest. But I'm not going to talk about that. There are other reasons why the forests are important. Oh, I'm going too fast. Is that it? Biodiversity. which means how many different kinds of plants and animals that live in an area. And the more, the merrier, right? I mean, you want to see lots of different things growing in different places, and that's good for the environment, and it's good for nature. So here we are in this particular hot spot, the eastern deciduous forest. You can see how extensive it is. It goes all the way to the Mississippi River. It's also a hot spot. This is a map of amphibian species richness, so how many frogs and salamanders are growing in live in different parts. Of course, the tropics are hot spots for biodiversity. Lots of stuff grows there. But you see here in the northern latitudes, this forest, this eastern deciduous forest, has lots of species of frogs and salamanders. Here's a map of plant species, and you can see the dark green in the same area. There are thousands of plant species that live in this type of forest, in this environment. So it's very important. It's next to the tropical rainforest. It's one of the most diverse biologies in the world. Forests filter water and purify water that flows into the rivers and into the bays. When the rain falls on the ground, the unprotected ground, even the water droplets, as they hit the soil, they can break up the soil, and then when the water runs across the surface, because it's not absorbed, then all that sediment and soil gets washed away, and it gets washed into the waterways and into the Chesapeake Bay and other estuaries. The forest, first of all, dampens the effect. The forest intercepts the rain as it first comes in. It stops the raindrops from hitting the soil and banging on the soil. And it also slows the flow of the water over the surface. So the water can, instead of running off and peeling all the soil and dumping it into the waterways, the water is trapped and sinks into the aquifers, into the groundwater below. And groundwater is important for agriculture. It's important for municipalities. Many cities rely on groundwater wells, and and probably some of you live in homes that depend on wells. And wells, that's groundwater. That's water that comes from rain that soaks into the ground and gets down deep where it can be stored and used for other purposes, including by the trees. So the forest clears the water and reduces the sedimentation and reduces the erosion that occurs, that would occur if it wasn't there. The forest carbon cycle. All plants take carbon dioxide out of the air and using sunlight make biomass, pretty much make everything that's living in the world comes from photosynthesis. I mean, the food that you're eating, it all comes originally from photosynthesis. Maybe the cow ate the grass that did the photosynthesis. But we all depend on what these plants are doing. And what forests do is, when there's enough light and there's enough water and nutrients, plants compete for light. So the sunlight is where the energy is coming from. So if a plant can grow tall, it can shade its competitors, and it can trap the light first. It can get the light first. So when you have the resources, what you find is that plants grow tall. They evolve to produce trunks and wood that allow them to stand tall and absorb the sunlight. And it turns out that trunks and wood, that's pretty stable stuff that can last for centuries. So this carbon that's being taken out of the atmosphere, this atmospheric CO2, then can be stored for long periods of time in the living tissue of the forests. Now, this is a graph of the amount of carbon dioxide that goes into the atmosphere every year. And this line here, this black line, is what we emit with fossil fuels. And that's been going up from the 1960s. We emitted maybe something like 2.5 gigatons of carbon, and now we're producing about 10 gigatons of carbon. We're adding to the atmosphere, and this is causing the atmosphere to go up. And you see little bumps. This right here, that's COVID. 19, when the economy of the world collapsed for a year, and we burned a lot less fossil fuels, and so the CO2 didn't go up. Well, or the emissions went down. This is an emissions graph. This line down here is how fast the CO2 is going up in the atmosphere. So all this is not showing up in the atmosphere, even though we're producing it. And that's because there are natural processes, things in nature that are taking the CO2 out of the air and storing it somewhere else. So we started here at 320 parts per million. It's a big number. It sounds like it, but it's parts per million. Now we're at 420 parts per million. And if this didn't happen, we would be at 500 parts per million, which is something we expect by 2030 or 2040. So there's this service that's being provided by nature that's slowing the effects of climate change by absorbing the CO2 out of the atmosphere. And a big component of this is carbon stored in the trunks of trees. Photosynthesis is taking it up and putting it in the trees. And that has changed over time to our benefit to some extent. This is a slide about the eastern deciduous forest history over the last 400 years. Right about the time of colonization, all of this was deciduous forest. All the way from the Mississippi east, it was all forested. Then as we developed and agriculture and logging occurred, the forests started to disappear, and by 1920, only 10% of the original forest cover, pre-colonial times, still existed. Now, since then, because agriculture and logging moved west, the Midwest, better agriculture there, even the logging went to the Northwest because they'd already cut all the trees down in the east, and there are plenty of good trees in the west. They haven't gotten there yet. So 40% have returned, and this is a satellite analysis of where the forests exist right now. Now, these are all regrowth. These are not old growth, virgin forests. This is probably a more accurate map of where those forests exist now. In fact, there are fewer now. It's very rare to find a stand of trees that has not been, is not regrowth from disturbance in the past.
Jim, was 1920 the low point?
Yes. Yes. The early 1900s, agriculture moved, most of it moved to the Midwest, and then land was abandoned, and so nobody was using it. It rains, it's warm, a forest grows. So, forest, during that time, returned to Quiet Waters Park. Here's a picture of the park. Here's where we are right now. We have this large expanse of forest. There's some cleared areas, but about 80% of the cover of Quiet Waters Park is forested. And some of them are young trees that have grown since the park was established, and some are over 100 years old. So that's about the time when agriculture was abandoned for the whole eastern deciduous forest. We have trees that are about that old here at the park. Now, this is kind of an example of what happens when a forest is abandoned. When an agriculture area is abandoned and allowed to regrow. This is an aerial photograph from 1952. Here's where we are right now. I mean, we weren't there when this picture was taken. But, and so there's all this clear white stuff is farmland. And I'm highlighting this particular spot. And the rest of it is forested, old forests. You can see them. Now, by this was, if you would have been here 2 talks ago, you would have found out that in the history of this park, the people who bought the park didn't want to continue the agriculture. They just let it let it go. They let it wind down on its own. So they stopped mowing or doing agriculture on this particular section. Well, in 10 years, just about 10 years, this is the same section. You can see it's a dense stand of tulip poplars. They're already probably 30 feet high, 20 to 30 feet high, just dense. Then, 35 years later, when the county acquired the land to make a park, you can see it's all completely forested. They're different. The forests look a little different than the old forests. And that views more recently. Here's a picture, a satellite picture. You can see the young forest. It's only 70 years old. It's they're tight, dense. They're dense. There's a lot of them close together. And you can compare this to this 120-year-old forest, where you can see the blobs of the individual tree canopies. Each canopy is, kind of takes a piece of the landscape of the sunlight, while these are much more crowded. And here's an example of looking up one of these. This is a trail, by the way. You can walk this trail, and it circles around this abandoned farmland. And these are the young trees. They grow close together. The branches stick straight up. There's hardly any, not very much undergrowth, plants growing underneath them. This side, older trees, bigger trunks, separated in space from one another. Branches are spreading at the top, large branches. There's dead material falling on the ground, and there's lots of undergrowth. So these forests, even after that period of time, are still different. And this is a mature forest. This is not a virgin or an old growth forest, but it's on its way there. So there's hope that someday those will be 200-year-old, 300-year-old trees. Now let's talk about trees. Take the forest from the trees. We have over 25 different species of trees. Trees being defined as something over 30 feet tall that are in this forest here at Quiet Waters Park. There's a tulip tree that's the most common tree in the forest. It's called Phalerodendron tulipifera, and I've always been unsure why it's called tulipifera. Is it because the flowers look like tulips, or is it because the leaves are in the silhouette of a tulip flower? I always thought it was that until I saw the flowers of it, and the flowers are pretty impressive too. Lots of oaks, different species of oaks. We've probably got, willow oak, northern red oak, chestnut oak, lots of different oaks that grow here. What'd you say?
White oaks.
White oaks, and this is a white oak. And it has acorns, very valuable food source for a lot of animals. We have American sycamore. These are beautiful in the winter. You walk through a gray forest and brown, dark gray stems, and you see these white, big trees, big white bark sticking, just glowing in the view. Black gum, tulip, tupelo, really pretty tree in the fall. It has shiny green leaves about this big, and then they turn red and orange in the fall. It's really beautiful. And we have some evergreens in the forest too, like the Virginia pines. They have little pine cones that are about this big, and but the trees grow pretty tall and pretty big, and there's lots of them in this forest. Now, forests may be expanding and growing in places where they haven't grown in 100 years or so, but they're not out of the woods yet. That's my joke. But anyway, current threats to the forests are invasive, non-native plants and browsing from the large deer population. Deer were kept in check for long periods of time because there were other predators. There were Native Americans, there were wolves, and there were mountain lions. Then, when colonization occurred and Western civilization took over the eastern part of the United States, the deer population crashed and went really low. But by the middle of the 1900s, the predators were gone and the humans were not hunting as much anymore. And now the population is just taken off. It's higher than it was before colonization. And the deer evolved to eat the native plants. That's what they eat. They eat the plants. Well, thousands of years they've lived together with the plants, native plants. But now we have invasive plants coming. They don't eat the invasive plants that much. They're not used to them. They haven't seen them before. They haven't evolved with them. So they continue to eat the native plants, and then the invasives don't have any competition, and they can just grow and take over and cover the ground and absorb that sunlight, which our native plants can't do. And this is an example. This is a deer fence. And on this side, there's lots of seedlings, tree seedlings, and things are growing. The deer can't cross into there because the fence is too high. And on the other side of the fence, where the deer are, is stilt grass, which is a very bad invasive plant, and we have it here in Quiet Waters Park. Here's another example. There's a dyke standing right there. And this is all regenerating forest. These are young tree seedlings. And this is what it looks like when the deer continue to browse the area. In fact, it's getting so troublesome, some forests are failing to reproduce the next generation of trees. This was a study published last year. These are all national park areas where they take intensive data for long periods of time. They've been studying the vegetation. And they found, if you look, you see the reddish and orange. Look at all those. Those are probable failure or imminent failure steps, which means that these forests are not going to grow back to the same forests they're predicted that they are now, because the seedling bank has been consumed by invasive plants and deer. So other kinds of plants are going to grow. I mean, there's light and there's water. There's going to be photosynthesis. There are plants that are going to come up, but it's not going to be the forest that's there now. It could be a bunch of plants that are unpalatable to deer and covered with vines. That's really a worrisome situation. So there are threats. Okay, another is logging, and I can't quite see it because it's so light in here. This is a satellite data analysis of forest loss, forest gain, loss and gain, and forest extent. So all this green stuff is where the forests are right now. The black stuff is agriculture or cities, things like that. And the colors here, this is Northern Virginia and South Carolina. All this area is industrial forestry. They grow things like loblolly pine, and they have a harvest rate of once every 25 years. They cut it down, make pulp, plant another forest. It's not deciduous forest anymore. It's agriculture. And you can see the extent of it. So some of these spots are red because they've lost. You can't see it. There are some places blue, which is forests that they planted and that are coming up and still growing. So this is not as big a problem here in Maryland, but you can see the extent. And this goes all the way down to Georgia and Alabama, this industrial forestry, which does take room away from the deciduous forest.
And your red cross in there is the park.
Yes, that's where we are. That's in Annapolis. Well, let's get a little closer, because another pressure on the forest is development. And I just zoomed in on this map, and I saw there were a few spots that showed that in between 20 and 2022 had showed forest loss. And there's one spot that had forest gain out here in the Cirque, in the Smithsonian spot. I checked that out too. So there's the spot I found. And then I looked at satellite data, historical satellite data. And so here's a picture in 1994. This area was forested. It had a few roads going through. And then in 2002, it had been cleared, and they put houses in. Now, everybody should have a place to live, and I understand, that these houses were of value to the people who bought them and lived there, enjoyed living there. But that kind of thing happens, and in fact, in Anne Arundel County, within a 4-year period, recently, almost 2% of the forests were lost to development in this county. So that's another threat to the forest. So the goals of my talk, in conclusion, just to wrap this up, was to highlight the unique and important characteristics of the northern deciduous forests and how their structure and history and future for the whole East Coast, from, east of the Mississippi, is reflected in this forest that we have here. The challenges, the invasives, the deer, the carbon sink, the high water quality that it provides, it protects the Chesapeake and Harness Creek. It's just a microcosm of what's going on off the total East Coast. There are threats, of course, to the native plants, excessive deer browsing, logging and development, and all of these things are related to what we've done in the past and what we're doing now and whatever we do in the future are affecting the forest and quiet waters. Now, these threats are complex and not easy to defend against. People want to live in houses. People need wood to build structures. There's many things that you have to balance in order to save the forest. But for sure, it's important, and probably to me, two of the most effective strategies would be to preserve existing forest land and allow forests to regrow on other cleared land. So that's my story. Did anybody have any questions? What I didn't mention was climate change and how that's affecting the forest. And the forests all over the world are changing in various ways. Sometimes they're moving north, sometimes they're moving north and leaving the south without forests. Species are changing, things like that. And that's another topic, and a long topic of active research, because climate change, believe it or not, is still slow compared to things like deer browsing and development and invasive plants. But those things are happening too to the forest. Yes?
I have two questions that I've heard you talk about that I think are interesting. The first is this one about forest disturbance.
Mm-hmm.
And you know what happens when that tornado came through a couple of years ago? Oh, that's the other. And the second one was, until you told me, I didn't realize how much carbon is in a tree. Like,
yeah.
And how you compare that to cars and stuff.
Yeah, I had it on the slide and I forgot to mention it. Thank you for that. So that little section of forest that I tried to, come on. Must be patient. This little section here that's been growing back, I calculated, takes up as much CO2 from the atmosphere as about 8 cars, gasoline-driven cars, would use in a year. And that's these young trees growing back. That's about 4 acres of land. So they're really contributing. Another thing I forgot to mention too is that these trees are very important in keeping the CO2 from rising, but they are also vast storages of carbon. And if something were to happen to that carbon, if the trees were destroyed, fire, or if the wood production disappears, it's going to go back up into the atmosphere, and all that advantage that we got from these trees soaking up the CO2 will go right back into the atmosphere, and we will have lost it. So not only are they taking it actively up, we've got to preserve it so it doesn't go back into the atmosphere. Yes?
So I have a question about, does a young forest, is it more actively capturing CO2 or compared to an old growth forest? I mean, is an old growth forest still capturing CO2, or is it just holding the CO2 that it's got in its wood and bark?
Yeah, that's a very good question. As you know, see the heights of these trees. You know that's sort of how is also a graph of how fast the carbon is being taken up by the forest. So at first it's really slow, and then it starts to shoot up. So it grows. These young forests are actually taking up carbon faster than old forests. They've got a lot more room. And they're crunched in. They don't have as much mortality, as much death, because when a tree dies, it'll stand for a long time, but once it hits the ground, it doesn't take long for it to decompose, and then it goes back into the atmosphere. So, and these trees don't have that mass and contributing to it. So the fastest growth is in this period, but it doesn't stop here. For complicated reasons. The canopy, old growth canopies are more complicated. They're structured, they're bumpy. The light gets in sometimes deep into the canopy because an old tree dies and it opens the canopy up and young trees can grow in. So you get actually a lot more light absorption and a lot more photosynthesis. And although ecological theory would say, well, sometimes the trees have got to grow up and then it's got to plateau. They can't take up any more carbon than they are going to release. But the evidence shows that these forests continue to, even after 100 years or 200 years, continue to take up carbon. And it's kind of a scientific mystery. And one of the conclusions is that the canopies get so complex, they absorb more light and they can do more photosynthesis. And the trees continue to grow no matter what. You've got a 200, 300-year-old tree. It's still growing. It's still putting down wood. Taking CO2 out of the atmosphere and putting it in wood. Again, the little rings are maybe really tiny, but then they're big around in circumference. And so the forests continue to take up the carbon, even as they get old. Any other questions? Steve?
So if you put man in this equation, and you took all the carbon that he produced, how would that compare to how much is produced naturally? Or another question is, if, say, man wasn't influencing period, would the carbon just stay at the same level, constantly cycling down to the earth and then back up again, etc.?
Yes. Yes. The CO2 was at 280 parts per million since the last ice age. Okay? The CO2 went down to 180 parts per million. I would throw the numbers, but you get a scale. 108 during the ice age. It was low CO2. The temperatures were low, and everything iced up. And it stayed like that for 10,000 years or more. And then the CO2 started going up, and it went up from 180 to 280. And then the ice age was over. And so then we were in what was called the Holocene. And it stayed 280 for thousands of years, until the Industrial Revolution, 1900. And then it started creeping up. So we went from 280 in 1960, we're at 320, and now we're at 420. So that's really how, in a natural system, the plants take up the CO2, they make biomass, it's eaten and decomposed, and that CO2 goes right back into the atmosphere, so it's a balance. So unless there's a source of CO2, there's no change. It just stays the same. Well, what happens, fossil fuels are photosynthesis that happened 100 million years ago. And it took 100 million years for it to form, a little at a time, a little at a time. It's down there. And now we're mining it and bringing it up, and in decades, we're burning carbon that was collected very little amounts over long periods of time. And we're immediately, all of a sudden, you have this huge source, completely unnatural source. I mean, CO2 does come from other places. Volcanoes are active, but again, and it's taken up by weathering of rocks. But these are things that take millions and millions of years to happen, and that's kind of what moves the CO2 around slowly. But this is unprecedented because it's happening in decades. Any other questions?
So old growth, what determines an old growth tree? What is that?
Well, age is one.
But I mean, what is that?
Yeah, it can be. I mean, old growth in this forest would be anything over probably 200 years old. But you go to the mountains of California, there are 4,000-year-old trees. They grow very slowly, and half of them are dead. Half of the tree is dead, or even more, but it's still alive. You can tell old growth, particularly around here, by its structure, and I tried to point some of those things out. Big diameter trees, tall, with branches that are just like mini trees coming out of the tops. Big canopies taking over the size of this room or more. One tree will intercept the light from this whole area. And then they're complex. They have undergrowth. There's openings where old trees have died. You see dead trees laying on the ground and have light come in, and the young trees. You'll have a mixed age of trees in there. But that's sort of what an old growth forest looks like. It's usually defined by age and whether it's been disturbed by humans.
So is old growth as a term sort of relative? I mean, there's also, people refer to ancient forests. I mean, is there a term for forests that have never been cut?
I think they're sort of synonymous.
Okay.
An ancient forest and an old growth forest and virgin forests, they're called like that. That haven't been disturbed by humans. Even Native Americans did not have a huge impact on the forest. They had impacts around their villages and things, but
They didn't have the technology.
right, the population or the technology.
Right.
You needed a system that you could harvest it and transport it away and make money off of it. Yeah, then you can really work things down. That will.
Great slideshow.
Thank you for coming. I hope it was interesting and you have some things to think about and appreciate the forests around here. Go forest day and think about the other things.
Do you think that Whitewaters would ever have an ex-closure to keep deer out to show people?
You know, I've talked about it. I've talked about it to a few people. And I had some ideas where we might do that. I think it'd be a great idea because it doesn't have to be, block your vision. You can look through it. It could be all it has to be is 8 feet high. And then people can look in and see the difference. And you probably have to have a team go in there and remove invasives also. Once a year, go in there and pull all the invasives. And then maybe a bunch of wildflowers that we don't see around here will be coming up. Orchids and other things like that we don't see a lot of here.
I've seen them before and it's really arresting.
Mm-hmm.
Well, like your slides, it's so dramatic.
It has a huge effect. Really, and it would be great. And combine that with weeding out the invasives. It'd be fun to have. It would be nice for it to be a good size. I mean, it'd be nice at least 100 by 100 feet or more. But maybe something like that can be done. I'd like to participate. Okay, folks.
Thank
Thank you.
Yes, thank you.